Assalamualaikum. Hi everyone. So in this subtopic of vectors, we will cover on del, divergence, and curl, and also directional derivative. Okay, so we go to the first one. So what is del? So when we are talking about del, so let's see the function of f is a scalar function of two variables. Okay, so its gradient, all right, its gradient is known as del f. All right, so if it is two variables, so meaning that your gradient is del f over del x, all right, and then I, and then plus with del f over del y, and then j. So this is for two variables. So let's say we have three variables, so we just need to add one more terms at the back where this one is for z. So meaning that we're gonna have del f over del z and then k. All right, so now you know what is del for two variables and how to find del for three variables. All right, okay, so let's say we need to keep in mind where the derivative operators appearing in the del operator add only on functions appearing to the right of the del operator. Okay, add only on functions appearing to the right of the del operators. Alright, so let's say we have two vectors, vector f and also vector r. Alright, so we want to compare between these two operations, between these two expressions. So the first one is del dot with function of r. Alright, and then we're gonna multiply with vector f, and then the next one is what if vector r we dot with del and then we multiply with function of f. Alright, so we're gonna see the difference. So for the first one of this one, alright, so del dot with r, so this is your del. Alright, so this is your del, and then this is your vector r. Alright, so we dot first. When we dot, so this is the product of our dot product. Okay, and then we're gonna multiply with vector of f, so this is vector f. So when we multiply, so del over del x, and then x, so we get 1. So this one we get 1, and then this one we get 1. Alright, so we're gonna get this one as the answer. So what if we do for the second one, which is vector r we dot with the del. Alright, so vector r, so r dot with del, so we get this one. Alright, we get this one, and then this is your vector f. Okay, so when we perform this is the multiplication. Alright, the multiplications, so meaning that this one gonna multiply with this one, and then this one gonna multiply with this one, and this one need to multiply with this one. Alright, so we get the answer as this one. So when you compare this one both, so it is not equal. Alright, it is not equal. Okay, so clearly we see that this one is not equal to this one. Okay, so meaning that, alright, meaning that it is common to omit the bracket in a vector expressions, but you need to know which expressions that make sense. Alright, which expression makes sense. Okay, so we go for the first example here. Okay, for example 1, so given a function of phi is equal to 2xz power 4 minus with x squared y, and the question asks you to find the gradient of the phi, and then we need to find the magnitude of the gradient at the point 2 to negative 1. So to find gradient, so gradient is also equal to the del of phi. So del, so meaning that you need to differentiate the function of phi with respect to x. So that one is your I term. And then to obtain your j term, so d phi, del phi over del y plus with del phi over del z. Okay, so that one is for k. So when you differentiate phi with respect to x, so you obtain this one, alright? And then when you differentiate phi with respect to y, so you obtain this one, alright? Because we just need to differentiate this one, alright? And then when we differentiate phi with respect to z, so we obtain this one, alright? So after we obtain the gradient of the phi, so they ask you to find at certain point, right? So 2 to negative 1, so meaning that you need to substitute this point into this expression. Okay, so when we substitute inside the expression, so we obtain this one. And then the question asks you to find the gradient of the magnitude of the gradient. So meaning that from here, alright, from here, so you just need to find the magnitude of this one, so meaning that square root, and then this term squared plus this term squared, and then plus with this term squared. So you obtain your magnitude of your gradient phi is equal to this one. Okay, so this is how you do for example 1. Alright, so next we go to example 2 here. So in example 2 here, you are given two vectors, vector A and also vector B. So they ask you to find the gradient of A dot with B. So meaning that you need to find, you need to perform dot product for vector A and also vector B first. Alright, so when you perform dot product, so I multiply with I plus J multiply with J plus Z multiply with Z. So you obtain this one, alright? And then after you obtain A dot with B, so you need to find the gradient of that one. So meaning that for I you need to differentiate with respect to X. For J you need to differentiate with respect to Y. And then for K here you need to differentiate with respect to Z. Alright? So when you differentiate respect to X, Y and also Z, so you obtain this one. Alright, so now they provide you with a point here, so meaning that you need to substitute this point inside this expression. So when you substitute inside the expression, so you will get this one. Okay, you will get this one as your answer. Alright, so actually it is not difficult. The important thing is you just need to know what is del here. Alright, how to find the del. Okay, alright, so next we are going into divergence and curl of vector fields. So when we are talking about divergence, so divergence is the dot product here. Alright, divergence is dot product. So meaning that if they ask you to find divergence of f, so meaning that del dot with f. Okay, so this is del, and then you need to dot with f here. Okay, so you obtain this one as your divergence. So if your divergence is equal to 0, so we call it as divergence free. Okay, so let's see what is curl. So divergence is a dot product, while curl is cross product between del and also f. Okay, so curl is cross product. So this is how we perform cross product. Alright, so let's say your cross product of del with f is equal to 0. So it is said that it is to be curl free or irrotational. Okay, alright. So let's go to example 11. So in example 11 here, they give you the function of the vectors of f, and they ask you to find the divergence of f at point 3, negative 2 and 0. So what you need to do is divergent f, so meaning that del dot with f. Okay, so when you need to perform dot product, so remember I multiply with I, J multiply with J, and then Z multiply with Z. So meaning that you're going to get this one. So you need to differentiate. So when you differentiate, you obtain this one as your answer. So we are given a certain point. So this is your point. So meaning that you need to substitute inside this expression. Okay. So when you substitute inside the expression, so you're going to get this one as your answer. Or you want to give in decimal places also can, but make sure that one is for decimal place. Okay. So for this example, it's quite easy. It's very direct. So let's go to the next example. So for this example 12, you can do by your own, alright? This one. Okay, let's go to example 13 here. Alright? So in example 13 here, they ask you to find the curl F. So meaning that divergence is dot product, so curl F is cross product. So curl F, so meaning that del cross with F. Alright, so this is your del, and then you need to cross with your vector F here. So you need to perform cross product. Alright, so if you want to find I, alright, to find I, you need to close the I column. Alright, so meaning that you need to multiply this one with this one. And if you obtain this one. Alright, so if you want to find J, so you need to close the J column. So you're gonna multiply this one with this one. Alright, but make sure the sign of J in front here is negative. And then the last one, if you want to find for K, close the column of K. So you need to cross this one with this one. Okay, so you obtain this one. So when you solve that one, simplify, so you get this one as your answer. And then for this question, they provide with certain value. So you need to find the curl F at that point. So what we need to do is we just need to substitute the point inside this expression. So when you substitute inside the expression, so we get this one as your answer. Alright, so this is how you find curl F. Okay, and then this one, example 14, you can try by your own as your exercise. Alright, so let's go to example 17 here. So given vector F, so they ask you to find grad divergent F. So at the point 3, 1, 2. So you know that divergent F is del dot with F, and grad is del here. So meaning that you're gonna get this one. Okay, you want to find this one. Alright, so what you need to do first is you need to perform dot product. You need to find the divergent F first. So to find divergent F, so del dot with F. Okay, del dot with F. So you obtain this one as your answer. Alright, then after you obtain the divergence, then only you can multiply with the gradient. So this is your divergent F, and then del for del, so meaning that you need to do del x, okay, for I, and then for J you need to differentiate with respect to Y, and then for K you need to differentiate with respect to Z. Okay, and then you obtain this answer, and then you need to substitute the point inside this one. So we need to substitute 0.312. So when we substitute inside this expression, so we obtain this one. Alright, so the important thing that you need to remember is, for if the question asks you for grad F, so meaning that one is del F. Okay, so that is vector. And if the question asks you to find divergent F, so meaning that del dot with F. So dot product is a scalar. And if the question asks you to find the curl F, so meaning that del cross with F. So that one is a vector product. Alright. Next, we are going into directional derivative. So for directional derivative, the important thing that you must know is, okay, you need to note that unit vectors are vectors whose magnitude is exactly 1. Alright, so when we are talking about magnitude is exactly 1, so let's say this is your unit vector. So when we find the magnitude of your unit vector here, and it is equal to 1. Okay, so to find gradient of fxy evaluated at the point x0, y0, so this one you have done just now. Alright, to find the del, and then let's say that one is 3 variables, so you already know this one. Okay, so now we want to find directional derivative and gradient for function of 2 variables. So directional derivative we write as d and then u, this one, and it is also equal to del f x0, y0 dot with your u. So u here is the unit vector. Okay, so it is very important for you to check whether the vector given is a unit vector or not. Alright, okay, so if it is 2 variables, so your directional derivative, you will get fx x0, y0 u1 plus with fy x0, y0 u2. So fx here means that you need to differentiate your function of f with respect to x, but this one is at x0, y0, so you need to refer your point given. Alright, you need to refer to your point given. Okay, so for directional derivative, okay, there are some properties that you need to know. So the direction of maximum increase, so let's say the direction of maximum increase, okay, so it is given by del f x0, y0. So the maximum value of directional derivative is, okay, is positive magnitude of this one. So that one is for maximum. But if the direction of minimum increase is given by negative, this one, so your directional derivative is negative magnitude of this one. So meaning that maximum, the sign is positive, minimum, the sign is negative. Okay, so the magnitude of del f x0, y0 is perpendicular to the level curve at fxy is equal to c. Okay, at the point of x0, y0, where fx0, y0 is equal to c. Okay, so this is important properties that you must know. So this is for 2 variables. So let's say you want to find directional derivative and gradient for function of 3 variables. It is just the same, but then we have another term which is for your z, alright, which is for your z, and the properties of this one is also the same, alright, it's also the same. Okay, so there are important remarks for you. Okay, if you want to calculate the directional derivative of fxy or fxyz in the direction of vector A, with the magnitude of vector A is not equal to 1. So meaning that that one is not a unit vector. So if the vector given is not a unit vector, so you must find the unit vector first. Okay, so how to find the unit vector? So this is the formula to find the unit vector. So meaning that vector of A over magnitude of vector of A. So that is unit vector. Okay. So the positive value of directional derivative of f indicates that the function is increasing, while the negative value of directional derivative of function f indicate that the function is decreasing. Okay, so positive means that increasing, negative means decreasing. Alright, so we go to example 4 here. Okay, so the question asks you to find the directional derivative of function f at given point 1, 2. So meaning that the point 1, 2 here is your point x naught, y naught. And they give you the unit vector here. Okay, so meaning that this is your u1 and this is your u2. Alright, so if they provide you with vector, so you need to check first, okay, whether that one is unit vector or not. Alright, so how to check? You need to find the magnitude of the vector given here. So find the magnitude of this one. So when you check square root and then squared plus this one squared, so you obtain this one is equal to 1. So means that that one is the unit vector. So you can use that one. If that one is not unit vector where the magnitude is equal to 1, so means that you need to find the unit vector of the vector. Okay, so now we want to find the directional derivative. So means that, so fx, so at given point x naught, y naught here, u1 plus with fy1, 2, u2. So to find fx here, so from here, you differentiate with respect to x, so you obtain negative 2x. And then to obtain fy here, differentiate this one with respect to y, so you obtain negative 1 to y. So now we need to find x at the point 1, 2. So what you need to do is substitute this point inside this one, substitute this point inside this one, so you obtain this one. Okay, so now you just need to substitute. So fx1, 2 is equal to negative 2, and u1 here, how to get u1? u1 is come from the unit vector here. Okay, plus with fy, so fy is equal to negative 1, and then multiply with u2. So u2 is set 3 over 2. So set 3 over 2 comes from your unit vector given here. Okay, so this is your directional derivative. So meaning that this one is negative. Okay, negative, so decreasing. Alright, so let's go to example 5. So find the directional derivative of, we go for a first. Okay, we go for a first. So given a function fxy at given point 0, negative 2. So in the direction of vector a. So first thing first, before you start answering this one, you need to check whether the vector given here, vector a given here, alright, is a unit vector or not. So how to check? So you need to find the magnitude of a. So when we find the magnitude of a, so we obtain set 5, so meaning that it is not equal to 1. So means that the vector a given is not a unit vector. So if the vector given is not a unit vector, so you need to find the unit vector of a. So to find unit vector of a, so you need to use this formula. Okay, so the formula of unit vector is equal to vector of a over magnitude of vector of a. So this is vector of a, and this one is the magnitude of vector of a. So you obtain this one as the unit vector of vector a. So it means that this one is your u1, okay, and this one is your u2. Alright, so now you can find the direction of vector a. So to find the direction of vector a, first thing first, okay, you need to differentiate with respect to x first. So when you differentiate with respect to x, this one, so you get 8y for x, okay, and then you need to substitute point 0, negative 2 inside, so you obtain negative 16. And then you need to differentiate with respect to y now. So when you differentiate with respect to y, so you obtain this one, and then substitute 0, -2 inside this one, so you obtain -2. Okay, so after that, you substitute inside the formula of directional derivative. So fx 0 -2 u1 plus with fy 0 -2 u2. So u1 here you obtain from here, from the unit vector. Okay, and then u2 here you obtain from the unit vector here. Alright, so when you substitute, so you obtain this one as your answer, and this one is negative, so meaning that the directional derivative is decreasing. Okay, alright. Now we see B. So for question B, not much different, but then for the vector, they give you in term of points. Alright, so meaning that from, let's say this one is point A and this one is point B. So we need to find the vector AB. So recall back what you have learned in EM1 before this. Okay, so to find vector AB, alright, what you need to do is B minus with A. So B minus with A. Okay, so to find vector AB, alright, B minus with A. So you obtain this one. And then for J, -3 pi over 8 and then minus with pi over 8. So this one is for J. Okay, so you obtain vector AB is equal to this one. Alright, now you need to check whether the vector is a unit vector or not. Okay, so when you check that one is not equal to 1, so you need to find the corresponding unit vector using the formula of this one. So when we find using the formula, find the unit vector, so we obtain this one. So it means that this is your u1 and this is your u2. So to find the directional derivative, so you need to find fx and fy first. Okay, so differentiate your function given with respect to x and then substitute the point. So which point you need to use? Alright, which point you need to use? So here you have point A, you have point, sorry, they are given this point, means that at point A, so you use point A. Okay, so substitute the point, this one, inside the equation of this one and this one, so you obtain -4.0. So now we can find the directional derivative. So the formula is fx, so at given point here and then u1, so u1 here comes from the unit vector here. Okay, plus with fy at given point and then multiply with the unit vector here. Okay, so you obtain this one as your answer. Alright, so actually it is not very difficult, just that you need to know how to find, you need to check the unit vector and all that. Okay, so we go to example 6 now. Alright, we go to example 6 now. So given a function f, and for the first one they ask you to find the maximum value of directional derivative. So we know that if that one is maximum value, so the magnitude of this one is positive. Alright, is positive. And for the second question, they ask you to find unit vector in the direction in which the maximum value occurs. Okay, so we go to the first one. So we know that del f, okay, del f is equal to this one. So it means that you need to differentiate with respect to x first for I, and then differentiate to respect to y for j. And then you need to substitute the point 2, 1 inside this one. Okay, 2, 1 inside this one, so you obtain this one, 1 minus with j. So they ask you to find the maximum value, so meaning that the magnitude is positive sign. So find the maximum value, so magnitude of that one, so we get Z2, so that one is positive, so this is the maximum value. Alright, so now we want to find the unit vector. So the maximum value occurs in the direction of I minus t. Okay, so when we plot, alright, when we plot in the Cartesian plane, so 1 minus with negative 1, so 1 and then negative 1, so it means that it is here. Okay, so to find the unit vector, alright, to find the unit vector, function the vector over with the magnitude of this one. So we obtain 1 over Z2 minus with 1 over Z2j. This one. So this is the unit vector in which the maximum value occurs. Alright? Okay. Alright, let's go to example 7 here. The temperature distribution in degrees Celsius across the surface of a rectangular metal plate is given by a function of T. So this is function T given. So the question asks you, what is the direction of maximum increase? So see here, maximum increase from 2, 3. So maximum increase, so meaning that del T 2, 3. And what is the rate of increase? So rate of increase, so it means that one you need to find the magnitude of this one. So given function of T, so to find direction, first thing first, you need to differentiate with respect to X first. And then you differentiate with respect to Y. And then you substitute the point given. Okay, so you get -4 and -12. And then we need to find the direction of maximum increase. So we substitute inside this one. Okay, we substitute inside this one. Because this one is del T 2, 3. Okay, so differentiate respect to X plus differentiate respect to Y. Okay, so you obtain this one. So now they ask you to find the rate of increase. So meaning that one is the magnitude, okay, of del T. So you find the magnitude, so you obtain this one. Alright, so 12.649 as your answer. Okay, so actually this one is not very difficult. Okay, you just need to know how to find the maximum value. Okay, all those terms you must be familiar with. Okay, so example 9 here, you can try. Okay, you can try by your own. So you should get your answer as 33.2265 here. Okay, so we have a few examples. So you may try as your exercise, and you have problem, you can ask me. Okay, because actually this one is not very difficult, just that you need to know what is the meaning of del, what is the meaning of divergent F, curl F, and how to find the directional derivative. Okay, for directional derivative, the important thing that you must check first is whether the vector given is a unit vector or not. How you want to know that one is a unit vector or not? The magnitude must equal to 1. Okay, the magnitude must equal to 1. And then you also must know what is the meaning of maximum increase, minimum. Okay, so that one you must know. Alright, so that's all for today. Thank you.